So my talk's on integrating new client-side frameworks such as React, Vue, Angular, things like that, with more traditional Rails apps. This talk's sort of a bit of a story about the process that we've been going on the beach for the last 3 or 4 months. So without further ado.
Is it working?
Hold on a second, there we go. Perfect. So I'm Simon Levy. I'm a front-end software engineer here. I'm mainly a front-ender, but I've done a fair bit of full-stack stuff in my past. I'm not a Ruby on Rails guru. I know a bit to get by, but not that much. So who here knows Ruby, heard of Ruby? A few. Who here has played around with Rails? Same people, roughly. Who's heard of the asset pipeline? And sprockets? Okay. So this talk, the first half, sort of a bit of an overview about how a Ruby app and a Rails app works and how we can sort of modernize it a bit. And then we're going to do a bit about best practices generally, and then cover a couple of new gems that you can use in Rails stacks. But before I do anything, this is a tweet that I tweeted, not this year, but last year, saying I'm going to make a blog and I'm going to do a talk. A year later, here I am, doing a talk at last. So if I can do it, because I hate talking, any of you guys can also do it and contribute to the Manchester tech community. So the bit of overview about how Rails works. Rails is a standard MVC framework. You've got views, models, and controllers. When a request comes in from the browser, it hits a web server, normally your Rails web server, gets routed through various routes, so that URL goes into a certain dispatcher that goes and hits a controller. And when it hits a controller, there'll be a view relating to that controller with HTML, and it'll grab some model data from a database, put it all together, and return you a view with data, HTML back through the web server and back into the browser. So it's a very standard MVC server framework. The templating language for the views is written in something called ERB files. It's similar to handlebars in a way, but different, and it allows you to interact with the instance variables out of your models, so you can access it's like a custom record, things like that. The asset pipeline is how assets are then served through your Rails server. So we've got the model and controller, and then we've got our router, and as requests come in, I say they hit a controller, the controller gets its data from the models and passes it to the view. The view returns the HTML, but what if that view needs something like an image or some JavaScript or some CSS or something like that, like an actual asset to serve? That's where the asset pipeline comes into it. So the asset pipeline is a build tool. So at build time, it'll take all your assets, so take CSS, JavaScript, HTML files, process it down a funnel, so various pre-processing, post-processing, things like that, and outputs assets onto the file system. Then when you build up your server at runtime, the views can talk through the Rails engine and grab these assets off the file system and then serve them back to the client. And that's basically how a traditional Rails app works and how a traditional asset pipeline works. What that looks like in a file system. So in a Rails app, a lot of things are done by convention. So the app's where your source code lives. Assets is where your JavaScript, CSS, and images live. All these are then pushed through the asset pipeline. You got your controllers in your controllers folder, your models in your model folder, and your views. The views are then split out into normally folders for controllers. So if we hit the home controller, so if you go to slash on a website, for example, you'll hit the home index, which will return some HTML. All of these views are then wrapped up in like an app shell. So the outside sort of frame of your website. That'll be your application HTML file. And that'll bring in, your head, any global script files, any global style sheets and things like that. So if we look at what some of this stuff contains, this is a very, very basic example application.js file. So this is sort of like the entry to your script. So you could have hundreds of different JavaScript files with different components in, but you need something to bundle that all together. And the way the asset pipeline and sprockets works is these sort of comments, they look like comments, but they actually do things. So require backbone pulls in the backbone framework. Require tree dot will pull in all your JavaScript files from this folder. So in your output is one application JavaScript file that contains all your source code files. Now, because you've pulled in 100 different source code files, you need a way of referencing that in your head, in your application shell. So Rails has JavaScript include tag, and then the name of the bundle essentially you want to include. So here we've got an application bundle, and we're including that application at this location, and that creates a script tag, so script with a source. Similar thing for style sheets, and a similar sort of idea for image tags. So this creates an image tag, and it'll go off into the asset pipeline and grab the correct location off the file system for my image PNG. So why do we need all that stuff? So the asset pipeline is really good at a couple things, but it's lacking on a lot of features. So for JavaScript, out the box this is, the asset pipeline gives us a concatenation of all that JavaScript. So you have 5 different JavaScript files. It'll put them into one file, just one in a block, in a block, in a block, in a block. Because of that, everything's just in the global scope normally, unless you use something like a client-side dependency injection, such as require.js, AMD, things like that. It can minify and uglify your JavaScript, which is great. That happened about 10 years ago, but it doesn't support ES6, so you can't write much new stuff. It can do CoffeeScript transpilation, which everyone stopped writing at least 10 years ago. And it'll also hash your files. So all those file names that it makes, so your application.js file will have a fingerprint hash at the end, so it cache busts when clients request that file. For images, it'll just put a fingerprint on the file name. And for CSS, it's just the basic Sass. It doesn't do much else apart from just the standard Sass framework. It does gzip all your assets, which is nice. So that all works really well for apps that were made 5 years ago in jQuery and Backbone, because they want to be put in one big file, and they're just basically scripting languages at that point. Or JavaScript is still a scripting language, but we used it as a scripting language at that point. But what about new frameworks like React and Vue? You can run React and Vue without Webpack. You can just include some scripts, but you can't use JSX and things like that. So how can we port React and Vue into a more traditional Rails app? So at that point, this is where we were on the beach about a couple months ago. We were thinking, how can we port modern frameworks into this traditional stack we've got? We could write a new app and put it on top of Rails, make Rails just this, this API where we can RESTfully hit Rails controllers, just return JSON, and have a completely different React app that sits on top and is a single page app. But what if you need to keep your monolithic code base? What if it's not an option? It's too big a stopgap to go, right, let's start a new app completely. So we want the tighter integration that the asset pipeline gives us, so we can reference the assets from within Rails, but we want to be able to use modern frameworks. So the asset pipeline sort of sounds a bit like Webpack, but an older, rubbishier, not as feature-complete version. So can we put Webpack and Rails together and make this super awesome project? So with Webpack, what are its big benefits? So all these things the asset pipeline can't do out of the box. Babel transforms, ES6 minification, tree shaking, code splitting, TypeScript support. Linting is a big one that the asset pipeline doesn't do. Source maps is really useful for debugging. Hot module reloading, nice developer experience. But the important thing is we still want assets as modules. So we want to be able to use in Webpack, sorry I missed a bit, in Webpack, you can think of assets as modules. You can bring an image into a JavaScript file. You can bring a CSS file into a JavaScript file. You can write any loader you want and use it in a JavaScript file, basically. So we want to be able to do that, but we also want that legacy of referencing these Webpack assets from our Rails views as if they were in the asset pipeline. This is where Webpack gem comes into it. And I stress the bit at the end. So the gem is called Webpacker, and that uses Webpack. Nicely not confusing. So the real key here is to allow us to use Webpack inside of a Rails app, we need the Webpack manifest plugin. And what this plugin does, when you run your Webpack build and Webpack generates all its assets out the other end, you need the Rails engine to know where to look for these assets, basically. Because without this mapping file, which is at the bottom, the Rails engine can't find any of these assets that Webpack's built because it's independent systems. So the asset manifest plugin outputs this manifest JSON file that has your entry files in Webpack and where they're located on disk. Rails can read that file in, and it can actually find these files to serve through the ERB views and things like that. Luckily, this is what's inside of Webpack gem. So how does that sort of look from a design point of view? So on the left here, we've got the traditional one with the asset pipeline. So again, at build time, your assets are put through the asset pipeline and outputted onto the file system. Rails reads in the output of the asset pipeline and can reference them in views. With the Webpacker build process, all these assets are now controlled by Webpack. So in your dev environment, you've got Webpack watching your assets. Whilst it's watching your assets, it's rebuilding them into its output files. And as it rebuilds them into an output file, an output bundle, it puts it in its own manifest. The Rails server then can read that manifest file in, and the views know where your new assets are built via Webpack. And then, because the views know the file location, it can just serve off disk that asset. So it's a similar sort of pipeline, but an external tool is doing that asset management. Now, when I mention Webpack, all front-enders normally go, that's the most confusing, complicated thing to set up. The configuration's impossible. I use React Create App and it works. I don't know how to configure it myself. So with Webpacker, there's essentially zero configuration. Famous last words. This is the Webpacker config file. It's a YAML file. You literally tell it where your source files are, so where your JavaScript is, where your HTML, where your CSS and images are. You tell it where your entry files, so Webpack uses an entry file to get into your bundle. So you say, here's the entry file, this references XYZ component, XYZ image, XYZ CSS file. And you say where to output those sort of bundled up, completed asset files. You've got some other configuration, but you generally don't have to change this. In development, you get hot module reloading for a Webpack dev server, basically for free. You just change that to true, and all of a sudden you've got a really good developer experience. With most Webpack configs, you have a webpack.conf.js file that's this crazy thing that no one knows how to change. This is the equivalent in Webpacker, the development.js file or the production.js file, depending on what environment you're in. You pull in Rails Webpacker config and you say, make that my config. And that config already does all the complicated stuff that you want. So it can do React, do JSX, do linting, do source maps and all this sort of thing. If you want to extend it, you can. There's some nice helpful APIs on Rails Webpacker that allow you to add in certain things. But essentially, that gets you off the ground. You don't have to configure anything. So what does a structure for a Webpack sort of Rails app look like? So this is all the same. We've still got assets, we've still got controllers, we've still got models, we've still got views with our home root view and our shell. But we get an extra Webpack folder down here at the bottom. And the Webpack folder contains our Webpack JavaScripts, our entry files for Webpack. They call them packs. These are your Webpack calls them modules, Webpacker calls them packs. And then you use your config files that I showed you just before. So your development config file and your Webpacker YAML file. So that's the extra bits it adds. It also gives you the Rails helpers. So I said we really want to be able to access these Webpack files from within Rails. So whereas before this was JavaScript asset tag, it now turns into JavaScript pack tag. And this then goes off into the Webpacker gem. The Webpacker gem picks up that manifest JSON file and it can find the application asset and it can serve it as a script tag here. So these helpers allow you to write references to the Webpack code, Webpack assets within traditional Rails ERB files. You get one for style sheets, you get one for the path to include an image, and because Webpack can do split chunking and code splitting, you get an extra helper for that one. So API-wise, interacting with Webpacker or interacting with the asset pipeline is pretty similar. You have these nice helper methods. So that's sort of a quick overview of Webpacker replacing the asset pipeline. Rails 6 is due to come out at some point this year maybe, and they're making Webpacker their #1 asset pipeline tool for JavaScript. So going forwards, any JavaScript written in a Rails app should be compiled using Webpacker rather than the asset pipeline and sprockets. Now, you can use all these amazing new tools, which is great, but with great power comes great responsibility. So you can add cool new JavaScript into your app, but does everyone have JavaScript? It's a nice little website, this, where it goes through a series of loops about that user that you want to target might not have JavaScript. So if the page hasn't loaded yet, your user didn't have JavaScript because they haven't downloaded the JavaScript. Did the request succeed? Maybe not. They're on a dodgy train connection. So on a dodgy connection on a train, so they might not have got that JavaScript bundle. Did it complete? Did firewall block it in the corporate enterprise? Did the ISP block it? Did they switch off JavaScript on the browser? Are they running in Chrome Data Saver? So a new feature in Chrome Data Saver a couple of months ago, if you're on a lousy connection and with Data Saver turned on, Chrome will actually stop downloading scripts altogether. So your site won't have any JavaScript at that point, and you have no choice about that. Do they have any plugins, browser add-ons installed that affect it? Is your CDN up? And eventually, if all this is true, you might be okay to say your JavaScript's loaded on your website and you can run React and things like that. But there's a lot of hoops to get through. So how do we introduce React and modern frameworks into Rails and Webpacker in a progressively enhanced way without taking sort of these SPA techniques of just rendering everything on the client? So an SPA, so something like React Create App, traditionally client-side rendered, you don't get anything until your JavaScript's ran. That's great for sites that you have to use, your business requires you to use, or you've got a big investment in. So things like Facebook, where you invest your data and your time, things like Trello, where you might have lots of data and things like that. Because sites like that, whenever you hit them, you're going to convert. You're going to spend lots of time doing things. You're going to write a post on Facebook. You're going to do something on Trello. And you're not going to go to a rival site because in a rival site, they don't have your Facebook account, for example. Whereas a multi-page application, more of a traditional e-commerce site, more how a legacy Rails app works, traditionally server-side rendered, lower conversion rate, so every single user that hits your site that goes down your conversion funnel counts. Because if you lose one user on a lower conversion rate, it hits you harder in your back pocket. And quite often, the users aren't invested. If you think about holiday booking, what On the Beach do, you can go to On the Beach and book a holiday. If the website's not working for you, you're just going to go to TUI or Thomas Cook or someone and book your holiday on there. But don't. So I did a couple of case studies on a couple of sites about how their sites work without JavaScript turned on. The first one is, I'm learning German at the moment, so I'm using Duolingo. The Duolingo app, Duolingo website, when you boot it without JavaScript, so if your JavaScript fails for one of those many reasons, it shows a splash screen, and the splash screen says, download our iOS or Android app. And that's all you get. But if you do turn JavaScript on, you get the nice single-page application. Now, a common thing it has is a word list. So there's a big list of words that list out all the words you've been learning recently. And if you click on one, it goes to the dictionary definition for it, so a separate page. Now, this looks like a link when you hover over it, but when you right-click on it and open in a new tab, you can't, because it's a span, which really annoys me, because I like to open lots of them in one go without having to scroll through this big list all the time. So semantic HTML is really important, even if your website works, because people like me that like to open in a new tab can't if you're using a span instead of a button or an anchor tag. Second example is my own website, the On the Beach website. We do server render the majority of our site, so even if you have no JavaScript, it should still work. You get a nice UI like this. The search form looks like it's working. The issue is our button, even though it's nested within a form with an action, our buttons have type button. So if you clicked that, it doesn't do anything, because that needs to be a button of type submit. And if it was a button of type submit, our form and our search form would work without JavaScript. It's like a one-line change that I haven't got around to doing. But because of that one little thing, our site technically doesn't work without JavaScript, even though we go through hoops of effort to server-side render a nice UI for you. Anyone here from the BBC? No? Good. Don't worry, it's good, this one. The BBC is really good at working without JavaScript. So on the left is full BBC page running with JavaScript. On the right is BBC page running without JavaScript. And as you can see all the articles. You can click on these because they're just links, and you can go through to articles and read them. The really nice thing I like is the menu at the top. So on the full site with JavaScript running, you get this nice, rich, interactive menu with the drop-down menu here and things like that. On the site without JavaScript, you get this little button. Now, you can't make a nice drop-down menu without JavaScript. So what do? They use something that every single site has, yet no one ever uses. They scroll the page down to the bottom and show you the footer with all the links in that would be in that menu. And they just use a simple hash URL, so that's a browser native thing to scroll the page, which I thought was a really nice way of getting around not having a rich menu system without JavaScript. And the final case study is Kitbag. Kitbag's quite a big e-commerce site. On the left, running with JavaScript and all the assets. On the right, when your assets don't load, you get a white page. And that is exactly the use case we don't want. Because in an e-commerce site, if I were to hit that on a train connection and it doesn't load, I might go, I'm using a different website, and they've just lost a customer. There is some stuff behind here which makes it even worse. So Kitbag uses Angular, and the way Angular works is it puts an ng cloak over the DOM, and because JavaScript wasn't running, it didn't remove the ng cloak. So behind this white screen is actually a website, but no one can use it because it's got a display none on it. So it's a pretty easy fix to fix that one as well. Just don't put the ng cloak on by default. But, you know. So to fix these issues, we could write more semantic markup. That'll fix some of them. But at the root of all this, there's an underlining issue of we have to server-side render this HTML because we can't always rely on the client doing it. Server rendering HTML is a bit of a minefield. There's a lot of different ways of doing it. So this is a nice link that I saw the other day, which sort of describes different ways of server rendering. So this is more your traditional multi-page one, where you server render everything on the server. You server render all your HTML on the server. This is how Rails traditionally works. And then you've got the opposite, where you have a single page app, everything's rendered on the client. That's how React Create App works and things like that. You get a white website until your JavaScript's ran. Your traditional sort of React server-side rendering is what's called SSR with hydration. So you run React on the server, you generate your HTML from your components on the server, but then you also run it on the client to add event listeners. That's what's called hydration. So you take the outputted React HTML, put your event listeners on, hydrate it with some interaction, but you don't make any new HTML on the client. And then there's two others that have sort of moved into the space at the moment, which is statically rendered apps. So at build time, your whole app is statically rendered. So you click build on your app, it outputs a ton of HTML files, and you just serve those HTML files. That's great for blogs and things like that that have very static content, that you write a blog, you update your site, you don't need a framework to then render that out for you because it's just static HTML. And the last one's things like, the other option is server client-side rendering, but with pre-rendering, where you basically render your shell, so the outside part of the website on the server, and then everything within that you do it on the client. That's how like Gatsby and ViewPress work. So there's a lot of different ways of doing server-side rendering. Pick the one that fits your app the best, I would say. But with Rails, we've got the issue that we've got a Rails environment. We don't traditionally have a node runtime. So there's a good tweet by Sam who said, all these modern frameworks, React, Vue, need a node runtime to do this server-side rendering. Very few of them, or none of them, you can use a completely different runtime. They need some sort of JavaScript runtime. And it's not always possible. A lot of companies run Docker containers. They can add a node environment into the Docker container and off you go. But if you're running a legacy monolithic Rails app that isn't in a Docker container, it's not always that easy to add a node runtime in. So what can we do to get a node runtime working in Rails that allows us to do server-side rendering in React within Rails? That's where the React Rails gem comes into it. So we'll do a demo. What do I want? So this here is the index view for our prototype app we're building. And the index view would normally, for a Rails app, contain a load of HTML. Our Rails app, however, calls off to React to do server-side rendering. And that's where this React component comes into it. So within our index view, we say, I want a React component to render here on the server. I want this React component to be the component of component/logo. You pass your React props in, and you say static pre-rendering, which means pre-render to static HTML. At this point, when the Rails server has routed your into the controller's gone off to get this view. Yeah. The view then goes, I've got a React component I need to render. The Rails React gem then delegates off to a sub-process. So the way Rails works is it runs in a process, or it can run in multiple processes. And the way React Rails works is it runs as a child process of the main Rails process. So this call here goes off to a child process that runs within something called exec.js. And basically exec.js is a facade for Rails to talk to a JavaScript environment. So you could be running Node, you could be running a V8 in memory, you could be running a mini racer JavaScript environment. Exec.js just abstracts it all away from Rails. So Rails just goes, make me an environment using whatever JavaScript environments there are on the machine. This goes off to the JavaScript environment, does the server render, and returns a string of HTML in this place. The same with the search form. We can pass in Rails variables. So these are actually Rails variables, instance variables, not JavaScript. We can pass that in. They get JSON serialized when they go through to the JavaScript environment. And again, that goes off and grabs the search form component and returns a string of HTML. What those components look like. So the logo just looks like a standard React component. That is literally a standard React component. There's nothing special about this. Search form container. Again, it's a standard React component that uses Redux as well. And there's nothing special in that file that says you're inside Webpack or anything like that. So what does that look like when you run it? So this is the prototype. And you can see, if we look at the network request, we've got the network request for the slash, which is that index file we were looking at before. And you'll see in line, we've got the HTML from that React component. So that's been rendered on the server. And the HTML for the search form that again got rendered on the server. And then it looks like that without any JavaScript running, a fully working site. React Rails uses that middle server-side rendering option, which is server-side render on the server and hydrate on the client. So you'll see, if we look at the actual DOM, there's this wrapper div around each component that got server-side rendered with the full props for that component in a JSON format. And what React Rails does is it runs React on the client, reads in this big blob of data, turns that into your props, runs hydrate, so React hydrate, makes sure that these props match up to what the server rendered. So the output of what these props give is the same output as what the server rendered. And if it's the same, you're happy. It just uses whatever was done on the server. If not, it re-renders on the client. And that's basically it. That's how you get React into a Rails traditional website without too much work. Now, this is sort of just a technical diagram of how that works. So with the view, as I say, it goes off to this exec.js environment. You can tell what JavaScript environment to run in, but all that's sort of abstracted away from you. You literally just put in your gem file what environment you want to use, and it just uses it. Other than that, the stack's exactly the same. So you can easily have a monolithic Rails app and pick one page and say, this page I'm going to go off to exec.js and server render this stuff in React instead of using traditional Rails ERB views. So what about performance? So this is using the mini racer JavaScript environment, and React Rails server rendering React is quicker than server rendering traditional ERB views. So React Rails can do in this prototype, can do 25 requests a second, whereas Rails ERBs can just do 23 requests a second. That meant just moving what we had over into React Rails meant we saved the user 0.2 seconds on time to first byte. The downsides, much more server load. So because you're in a JavaScript environment as well as a Rails environment, you've got more CPU load and it uses a lot more memory. That depends on if you're using Node or Mini Racer as your JavaScript runtime on the server, it varies quite a bit, but you generally use up more resources. Other pain points. React Rails is backed by Facebook. It's made by the React team, or part of the React team, but few major companies are using it yet. Server-side rendering debugging is very hard because of exec.js. It's quite hard to debug. It's possible, but it's quite hard. The way it works means code splitting is quite hard, so some of the benefits you gain out of Webpack, you lose using React Rails. But there are ways around that. You have to write some custom functions. If you've got Rails engines, it's particularly hard to use, as I found out today and yesterday when we've been trying to put a Rails engine into our app. It doesn't play too well with React Rails. You can get it working, but it's a bit of a pain. So it's more resource intensive, and there are alternatives as well. So there's Hypernova, React on Rails, and Hyperstack that work in roughly similar ways, but slightly different ways. And if React Rails doesn't take your fancy, there are some alternatives. That's my talk pretty much. Because you're here, I feel like I had to put a hiring slide in. We are hiring it on the beach. We're hiring front-enders, Ruby developers, .NETers, things like that. So if you're interested, come talk to us. Any questions?